This lesson is on adding and subtracting rational expressions. We're going to start with a very simple example. Let's say we had to add the two fractions 1/3 to 4/3. To add fractions, we need a common denominator, and we do have that here. It's a 3 already. I just add the numerators together like that, and I'd have 5/3. And this one doesn't reduce any, so I'm done. It is exactly the same for rational expressions. We have to have a common denominator. For example, x over 5 plus 3y over 5. We have a common denominator of 5, so this would be x plus 3y over 5. And we're done. Seven over 2y squared minus 11 over 2y squared. I have a common denominator here, so I can subtract the numerators. 7 minus 11 is negative 4 over 2y squared. Now this one we're not quite done because I noticed that I can reduce it a little bit. Always check to see if your answer that you have at the end will reduce any. 4 over 2 there reduces to a 2, so this is negative 2 over y squared. And that's my answer. Let's try another. Let's look at 2y minus 1 over y squared plus y minus 2 minus y over y squared plus y minus 2. We have a common denominator, so I can subtract the numerators here. So I got 2y minus 1 minus a y. These are like terms, so I'll combine those together. And that would give me 1y minus 1 over y squared plus y minus 2. Now, once again, on this one I don't think I'm done either, because if I factor the denominator, we will get something to cancel away. The denominator factors to y plus 2y minus 1. That means the y minus 1s will reduce down to a positive 1. And I am left with 1 over y plus 2. Okay, so once again, this is another example of where I subtracted my fractions, got an answer, but that answer reduced down a little bit. Let's take a look at this. A over a plus b over a plus b. We have a common denominator of a plus b. Adding the numerators together, I get a plus b over a plus b, which of course reduces to 1. M over m squared minus p squared plus p over m squared minus p squared. I have a common denominator, so I can combine the two fractions into one. M plus p over m squared minus p squared. But here's another one where this will reduce a little bit. Notice that I have a difference of squares pattern in the denominator. That's m plus p, m minus p. Therefore, I can get rid of these m plus p's, and I'm left with 1 over m minus p as my answer. One or two more here where we have a common denominator already. 3x minus 1 over x plus 2 minus x minus 5 over x plus 2. I have a common denominator of x plus 2. What I have to be careful of here is that I am subtracting this numerator, so I have to distribute that negative sign to the x and the negative 5 there, which would give me 3x minus 1 minus an x and plus a 5. Combine your like terms. I've got 3x minus 1x, which is 2x, and I've got a negative 1 plus a 5, which is a positive 4. It looks like we can reduce this one as well. I could factor 2 out of the numerator, and then I can reduce that right there, and it looks like my answer is just 2. Okay. Let's look at one now where we don't have a common denominator. Suppose I had to add the fraction 7 over 15 plus 5 over 12. I would need a common denominator, the least common denominator. That's what LCD stands for, least common denominator. There's various ways to get it. One way is this. I could write out multiples of 15 and 12 and see which one they have in common. Multiples of 15 are 15, 30, 45, 60, and so on, 75. Multiples of 12, 24, 36, 48, 60, 72, and so on. And notice that the first one that they have in common is a 60. And so the LCD, the least common denominator for 15 and 12, is 60. And there are other ways to get the common denominator as well. So I have to multiply this fraction by a 5 over 5 because that will give me a 60 in the denominator. This one has to be multiplied by 4 over 4 because that's what gives me 60 in the denominator there. You must always make sure that you're multiplying by something equal to 1. Equals 1. Equals 1. It has to be a 4 over 4 or 5 over 5 or an x over an x. It has to equal 1 or else you change the value of the problem. This is 28 over 60. This is 25 over 60. Add those together and we got 53 over 60. And that's our answer. And that, well, it doesn't reduce, so that is our answer. When we do not have a common denominator, we have to do basically the same thing for rational expressions. For example, 5 over 2p squared plus 3 over 8p. Let's see if we can find the LCD here. The least common denominator for 2 and 8 would be an 8. And I have variables on here. When we have variables, this is very easy. All you do is you go with the largest one. And so since I have p to the first, and the largest exponent that is, the largest exponent on the variables is the one you use. We have a p to the first here, and we have a p squared there, and so I have to have p squared in my least common denominator. Use the largest exponent. The LCD is 8p squared. That means that I will have to multiply this fraction by just a 4 over 4 to get the common denominator down there. And this fraction needs to be multiplied by a p over p. This gives me 20 over 8p squared plus 3p over 8p squared. I now have my common denominator, so I can add the numerators together. My answer is going to be 20 plus 3p over 8p squared. And there it is. Nothing reduces. That's my answer. Let's try another one similar to that. Let's look at this one now. 7 over 18 a cubed b minus 2 over 9ab squared. The LCD for 18 and 9 is an 18. And since the largest a's I have, exponent of a's I have is a cubed, I have to have an a cubed in the LCD. And the largest exponent for b is here, b squared, so I have to have a b squared in the LCD. Remember, use the largest exponents that you see. Okay, there's the LCD. To get the LCD in the denominator for this fraction, I'm going to have to multiply this by just b over b. That's all it needs. And this fraction needs to be multiplied by a 2a squared over 2a squared. That will give me the least common denominator down there. Let's multiply here. I've got 7b over 18a cubed b squared minus 4a squared over 18a cubed b squared. I've got my common denominator. I can now combine this into one fraction. 7b minus 4a squared, all divided by 18a cubed b squared. And that will not reduce, and so that is my answer. 2 over y minus 1 over y plus 4. The LCD here is just the product of both of them. Y and y plus 4 are just two completely different factors. And so my LCD is going to be a y times a y plus 4. I just multiply them together. It's as if you had, let's say you were multiplying 1/3 plus 1/5. Well, the common denominator for 3 and 5 would be 3 times 5, 15. It's the same reasoning. So if this is my LCD, then I have to multiply this fraction by a y plus 4 over a y plus 4. And this fraction needs to be multiplied by a y over a y. Let's distribute up here. That's going to give me 2y plus 8 over y times y plus 4. And right here, 1 times y is just y, or minus a y, over y times y plus 4. I've got my common denominator. I can now combine this into one fraction. 2y minus this y is a 1y, and then plus 8. And nothing reduces there, so that is my answer. I've subtracted the two fractions. Here's another one very similar to that. 6 over r minus 5 over r minus 3. Just like the last one, the LCD has to be the product of the two denominators, r times r minus 3. So this fraction has to be multiplied by an r minus 3 over an r minus 3. And this one multiplied by an r over an r. Distribute the 6 up here, so that's 6r minus 18 over our common denominator. And over here we got minus 5r over our common denominator. (3r minus 5r is negative 2r minus 18. I could, let's see. I could factor a negative 2 out of the numerator, but, oh, wait a second. Wait, hang on. I goofed. Let's go back and fix it. I'm sorry. 6r minus 18, but I wrote a 3, didn't I? So that's a 6. And so 6r minus 5r is 1r. Caught my mistake. So my answer is r minus 18 over r times r minus 3. and that will not reduce, and so that is my answer. Almost missed that mistake. Okay, moving on. Let's do another one. 2 over y minus 2 minus y over y minus 1. Y minus 2 and y minus 1 are two completely different factors, and so once again the LCD is just going to have to be the product of the two. That means I'm going to have to take this fraction and multiply it by y minus 1 over y minus 1, and this fraction will have to be multiplied by y minus 2 over y minus 2. That gives me the common denominator of y minus 1, y minus 2 under each one. Like that. Up here I have to distribute. This is 2y minus 2. Up here we have y squared minus 2y. I have my common denominator. I can now combine this into one fraction. We've got a negative y squared. Remember to distribute the negative sign. Negative y squared. We've got a 2y, that's plus a 2y, which is 4y. Oh, let me change the color here. Plus 4y. And then we have also minus 2 right here. Oops, wrong color. Minus 2. Okay, so remember you have to distribute that negative sign there and then combine your like terms. Nothing reduces here, and so this is my solution. Okay, just a couple more. Y over y minus 2 plus 8 over 2 minus y. Now, right now those denominators are not the same, but I could easily make them the same. All I've got to do to reverse 2 minus y and make it a y minus 2, I just factor out a negative 1. I think we did that in a previous section. So this becomes y over y minus 2. I'm going to factor out a negative 1, and that becomes now y minus 2 as well. It just reverses the terms. Well, 8 divided by negative 1 is really negative 8. So I could write this as really a subtraction problem now. This is y over y minus 2 minus 8 over y minus 2. I have my common denominator, so I can combine these fractions into one. This is y minus 8 over y minus 2, and I'm done with that one. Okay, let's look at this one here. We've got 3 over x minus 2 plus 5 over x minus 6 over x squared minus 2x. Now what I'm noticing here is that this factored is really x times x minus 2. Let me write that on the side. If you factor that, that's x times x minus 2, and that happens to be the same factors over here. That's the LCD. X times x minus 2. That means that I'm going to have to multiply this fraction by an x over an x to get the common denominator, plus this fraction will have to be multiplied by x minus 2 over x minus 2 minus 6 over x times x minus 2. This one already has the common denominator, so I don't have to do anything with that. X minus 2 is now under each fraction. In the numerators, we have 3x. Here we have 5x minus 10. And over here, minus 6. Okay, we can now combine this all into one fraction. Common denominator is x times x minus 2. We've got 3x plus 5x, which is 8x, minus 10 minus a 6 is minus 16. Now, it looks like on this one, if I do factor the numerator, I can reduce the answer. I can factor an 8 out of the top, like that. I can then reduce or cancel the x minus 2's. And so my answer is just 8 over x. So that whole problem just simplifies to 8 over x. Okay. M plus m squared minus 2m minus 3 minus 2m minus 3 over m squared minus 5m plus 6. The first thing I'm going to do is factor those denominators. That's m minus 3m plus 1. This one over here is, what is that? That's m minus 3m minus 2. The LCD then, I'm noticing I have an m minus 3 here and 1 here, and so I'm going to need an m minus 3. You don't need two of them because each one is only to the first power. I have an m plus 1 here, so I need an m plus 1. And I have an m minus 2 here, so I need an m minus 2. So my LCD is all three of those factors. That means that I'm going to have to take this fraction and multiply it. What factor is it need? It needs an m minus 2. It needs this m minus 2 here. So m minus 2 over m minus 2. And this fraction needs to be multiplied by, it's missing the m plus 1, so m plus 1 over m plus 1. That gives me my common denominator under each fraction. Like that. In the numerator, we have, let's see here, we have to take this and distribute, or actually FOIL. We can use the FOIL method here. We got m times m, that's m squared, minus 2m plus 4m is a positive 2m, and we got minus 2, negative 2 times positive 4 is negative 8. Same thing over here. I've got to FOIL that together. So that's going to be a 2m squared minus 3m and plus 2m is negative 1m. And then we've got negative 3 FOILed out. We can now combine this into one fraction. Remember to distribute your negative sign. So we've got m squared minus 2m squared leaves me with negative 1m squared. We've got 2m plus an m, which is 3m. And we've got a negative 8 plus a 3, which is going to give me a negative 5, that's right, negative 5. And that will not reduce, so that is my answer. Let's try one more large problem like that. to end the section. Let's take a look at 5 over x squared plus 10x plus 25 plus 2 over x squared plus 7x plus 10. First thing I'm going to do is factor those denominators. That's x plus 5 times x plus 5. This one over here, if you factor it properly, is x plus 5, x plus 2. Now x plus 5 over x plus 5 is actually x plus 5 squared, so I'm going to write that as squared. Let me get rid of that there. That's x plus 5 squared. Okay. Now for our LCD. I see an x plus 5 down there. So I need an x plus 5, but remember you have to, when it comes to variables, you have to use the highest exponents that you see. Over here we have x plus 5 to the first. Over here we have x plus 5 squared. So on the LCD you're going to need 2 of them, the largest exponent. I have an x plus 2 here, so I'll also need 1 of those. For this problem, my LCD is x plus 5 squared times x plus 2. That means I'm going to have to multiply this fraction by the x plus 2. And this fraction needs to be multiplied by the extra x plus 5. Like that. That then will give me my common denominator under each fraction. There and there. In the numerators, let's see what we have. 5x plus 10. And up here we've got 2x plus 10. We can now combine the numerators together and get, let's see, 5x plus 2x is 7x, plus 10 plus 10 plus 20. Nothing reduces. That is our answer. And that is how we add and subtract rational expressions.